Hey everyone, welcome back to Trigonometry. Today we're in section 2.3 and we're talking about approximations of trig function values. So approximations means the calculator is involved now, and so we're going to be getting calculator approximations of trig function values. So in other words, putting in an angle and getting a trig function value. And we're also going to talk about calculator approximations of angle values, which means we're going to put in the function value and get the calculator to give us back the angle. So let's get started. So first of all, everything that we're doing right now is in degrees. So you want to make sure that your calculator is in degree mode. And I'll show you how to do that in just a minute. And then you might have noticed on your calculator that you have buttons for sine, cosine, and tangent, but you don't have buttons for cosecant, secant, or cotangent. And that's because we're expected to just use the reciprocal button to get those. Okay, so let's take a look at the calculator together. I was talking to you about the degree mode, so you can see the DEG indicator down here in the lower right corner of the screen. If you don't have that, then it means your calculator is set in some other mode. And so to change that, you will hit this DRG button right here. So when you do that, you have degrees, radians, and gradians. Now we will not be using gradians in this course, but we will be using radians from chapter 3 and onward. Right now we're in degrees. So to change the mode of the calculator, if you need to do that, you just arrow over to the unit that you want and press enter. Now because we're in degree mode already, it means that we don't have to use the degrees, minutes, seconds button to specify degrees unless we need to differentiate between degrees and minutes like we will on this example. So let's go ahead and evaluate the sine of 49 degrees and 12 minutes. So first just hit your sine button and notice that it automatically opens a pair of parentheses for you on the screen. And then you're going to enter 49 degrees, and we remember how to do this. So the degree indicator is already selected, so just press enter and then put in your 12 minutes. And now if we had more to the expression that we were entering, we would need to close the parentheses and continue with our expression. But because that's all we need to do, the calculator will actually close the parentheses for us when we press enter. So I'm going to go ahead and do that. And with just a few exceptions, the trig function values are always irrational numbers. And so that means we'll have to decide how many decimal places to round off to. Now when you do your homework in MyLab, the MyLab instructions will always tell you how many decimal places to keep. Throughout this video, I'm going to keep 4 decimal places whenever we evaluate a trig function. So if we want to round off to the 4th decimal place, then we look at that 4th decimal place and it's a 9. And then we look at the 5th decimal place and we decide if that number is big enough to make the 9 round up or not. And of course anything 5 or more is big enough to make the previous number go up. And you can see we've got a 9 here, and so that's going to make this 9 go up to 0. Now just like an odometer on a car, if this 9 rolls to 0, then the next number is also going to roll. So this number is going to roll to 7. And we come out with 0.7570. Now if you don't like the hassle of having to fiddle with the degrees, minutes, seconds button, let me show you another way to enter this 49 degrees and 12 minutes that you might find helpful. So what you can do is just hit sine, and now we know that there are 60 minutes in a degree. So this 49 degrees and 12 minutes is really 49 plus 12 sixtieths of a degree. So I'm going to put 12 over 60. So you see what I've got here? The calculator understands this is all in degrees, and I've got 49 degrees plus 12 sixtieths of a degree. That's just another way of saying our 12 minutes. And then when I press enter, I get the same answer. So now let's look at part B. So we're asked to find the secant of 97.977, but of course when we look at our calculator we don't have a secant button, but we remember that the cosine is the reciprocal of the secant. So there are a couple of different ways that you can enter this. One is, if you know ahead of time that you're going to be doing a reciprocal, you can just put 1 over and then enter your trig function. So 1 over the cosine of 97.977 and then press enter. And rounding off at 4 decimal places, we get negative 7.2059. And here's another way of getting the secant. You can just go cosine of 97.977, press enter, and there's your cosine value. And then you can get a reciprocal of that number. So you can go reciprocal of, and then equals, and there's our same answer. So this x to the negative 1, you remember from algebra, means 1 over x, and so this is our reciprocal button. Okay, now for part C, we have 1 over the cotangent of 51.4283. But we know that another way of saying 1 over something is to say the reciprocal of that something. So 1 over cotangent is the same as reciprocal of cotangent, which is tangent. So 1 over the cotangent of 51.4283 is just tangent of 51.4283. So let's enter tangent of 51.4283. And we get approximately 1.2539. Now on part D, there's nothing fancy about this one, sine of negative 246 degrees, but I do want to point out to you that we can't use the minus key on our calculator. The minus and the negative are not the same. So I know that when we're talking, we sometimes use them interchangeably, or some people do, but this is the minus button on your calculator, and this down here at the bottom is the negative button below the 3. And so if you want to enter sine of negative 246, you need to hit sine of negative 246 degrees. If you enter the minus, it will give you an error. So approximately 0.9135 is the sine of negative 246 degrees. All right, now let's get the cosecant of negative 317 degrees in 36 minutes. So we're going to remember that the reciprocal of cosecant is sine, and so cosecant of this number really means 1 over the sine of that number. And so let's go ahead and enter 1 over the sine of. Now you can use either the degrees, minutes, seconds button, or we can adjust the trick that I showed you a while ago just a little bit. So first let's do it with the degrees, minutes, seconds button. So negative 317 degrees and 36 minutes. Arrow over to the minutes indicator and then press equal. Okay, it recognizes that whole thing is negative, and so we press enter. And that cosecant value is approximately 1.4830. Now let me point something out to you here. As we're going through these values, we need to always keep in mind that the sine and the cosine have to be between negative 1 and positive 1. The secant and the cosecant have to be outside of negative 1 and positive 1. They can't be between. So if you keep that in mind, that will help you stay on track and sometimes avoid careless errors. So for example, right here, I know that 1.4830 is not between negative 1 and positive 1, so I know that makes it a valid cosecant value. If I had forgotten to use the 1 over so that I was getting a reciprocal, if I had just entered the sine of this angle, then I would have gotten an answer between negative 1 and positive 1, and I would have known that that's not a valid cosecant number. So just being aware of the range that your answer is supposed to be in is helpful sometimes. It just keeps us from making silly mistakes. And now let's go back and try this again, but without the degrees, minutes, seconds button. So again, I'm going to start with 1 over sine, and again, I'm going to enter my negative 317 degrees, but now instead of adding 36 over 60, I need to actually subtract 36 over 60 because my angle is negative, so I need what I'm tacking on to also be negative. So negative 317 degrees minus 36 sixtieths of a degree, and there you can see we got the same answer. So now in part F, we've actually got a quotient here. So we've got sine of 77 degrees divided by cosine of 77 degrees. So let's just enter it exactly the way it's written. So sine of 77 degrees, and you know we don't have to enter the degree symbol, But because there is more to the expression, we do need to close the parentheses here. So now I can press divided by cosine of 77. And I don't have to close the parentheses this time because now I'm done with the expression, and when I hit equal, the calculator will close those parentheses for us. And we're getting an answer of 4.3315. Now, you might remember from the end of section 1.4 that sine divided by cosine is tangent. So I wonder what would happen if we hit tangent of 77 and then enter. And look, it's the exact same number. Okay, now we need to talk about the inverse trig functions a little bit, and we're going to start off with a review of how inverse functions worked in algebra. So in algebra, you probably remember, inverse functions reverse the input and output of a function. So you remember function notation? If f of 3 equals 5, then we should be able to find an inverse function so that f inverse of 5 equals 3. You remember talking about inverse functions in algebra? All the inverse function does is it makes the function run backwards. So if f of 3 equals 5, then f inverse of 5 equals 3. Now we can do the same thing with trig functions whenever we know a trig function value and we want to find out the angle that gives that value. So you know in the last example, we put in a function and an angle, and the calculator gave us a function value. If we need to go backwards, if we need to start with the function value and get the calculator to tell us the angle, then we need to use the inverse trig functions. Now there are some limitations on inverse functions. There's a lot more to them than what we're going to see today, but we will learn more about inverse trig functions in Chapter 6. For now, just know that if you have a function value and you need to find the angle, then you must use an inverse function. Now for sine, cosine, and tangent, this is pretty straightforward because we have inverse function buttons for each of those on our calculator. We have an inverse sine, an inverse cosine, and an inverse tangent. So to find an angle when you know the trig function, what you'll want to do is restate the function in inverse form by reversing the input and the output. If you can write it, then you can enter it in the calculator. But if you don't know how to write it, then you're going to have trouble entering it in the calculator sometimes. So let's practice learning how to write it correctly. If the sine of x is 0.5231, then the sine inverse of 0.5231 is x. Do you see what I did here? I changed from the sine function to the sine inverse function, and I swapped the input and the output. See, over here, x was plugged into the sine function, but over here in inverse form, the number is plugged into the inverse sine function, and the x is the result. And that's what we want, because we want the calculator to give us the angle whose sine is 0.5231. So once you get this written down, you can enter this in the calculator. And what we're going to see in a minute when we go back to the calculator is that for sine, cosine, and tangent, the inverse function is the second function of each of those buttons. So here's example 2. And it says use a calculator to find an angle theta in the interval from 0 to 90 degrees that satisfies each condition. And the first one says the sine of theta is approximately 0.9677. So before we go to the calculator, we need to restate this in inverse form. So if the sine of theta is this number, then the sine inverse of this number is theta. Now we can go to the calculator. So here we are back at the calculator, and let's take a look at the buttons that are available to us. We are familiar already with the sine, cosine, and tangent, but look at the second function for each of these buttons. These are not reciprocal buttons. Remember, this is the reciprocal button. We can do a reciprocal of any number using this button. So this sine to the -1, it's not really to the -1. Remember, sine is a function. So that -1 is an inverse indicator. So this is sine inverse, cosine inverse, and tangent inverse. And of course, because they're written above the button, they are the second function, and so we'll use the second button to access each of these second functions. So now to get sine inverse, I go second, and you can see the second indicator right there in the lower left corner, sine. So second sine gets us that sine inverse function, and now we can enter 0.9677 equals approximately 75.4 degrees. And because these are angles, I'm only going to keep one decimal place. We really don't need 4 decimal places on angles, but I do like to keep at least 4 on function values unless the instructions state otherwise. Okay, for part B, same thing. Tangent of theta is approximately 1.0546, and that means that the tangent inverse of 1.0546 is approximately equal to our theta that we're looking for. And now I can enter that in the calculator. So I want this inverse tangent here, so I'll go second function, tangent, and then enter the tangent value, 1.0546 equals, and we can see theta is approximately 46.5 degrees. Now, what if you're given a cosecant, a secant, or a cotangent value? We don't have buttons on our calculator for inverse cosecant, inverse secant, or inverse cotangent. So since we don't have those buttons, what we'll have to do is use reciprocal identities to transform cosecant, secant, and cotangent into sine, cosine, and tangent, and then we'll be able to restate in inverse form and go on just like we did in example 2. So here we are in example 3, and it says use a calculator to find an angle theta in the interval from 0 to 90 degrees that satisfies each condition, and the first one is the cotangent of the angle we're looking for is approximately 1.4746. So, if we had an inverse cotangent button on our calculator, we could do this exactly the way we did example 2. But we don't have that button. So what we'll have to do first is use our reciprocal identities to restate this as a tangent. So if the cotangent of theta is this number, then the tangent of theta is 1 over that number. Now we can switch into inverse form. So now we can say the tangent inverse of this fraction is approximately equal to theta. So you see how that works exactly the same way it worked in example 2. And so you would now go to your calculator and hit second tangent to get the inverse tangent function, and then enter 1 over this decimal, and then hit equal, and that will give you theta is approximately 34.14 degrees. Now here I have rounded to 2 decimal places, but remember you'll need to read the instructions in MyLab to know how many decimal places to keep on the answers in your homework assignment. And then for part B, we have secant of theta is approximately 2.74962. And so same thing again, because we don't have an inverse secant button on our calculator, we need to restate this using a reciprocal identity. So if the secant of theta is this number, then the cosine of theta is 1 over that number. And now we can restate in inverse form. So cosine inverse of this fraction is approximately equal to theta. And you know how to enter this expression on your calculator, and then you'll get theta is approximately 68.67 degrees. Okay, for example 4, I've come back to the calculator, so let's look at it together. It says use a calculator to evaluate each expression, and here in part A we have sine squared of 36 degrees plus cosine squared of 36 degrees. And the important thing to understand here is that when we write a squared function, we put the exponent next to the function. We've already talked about that and we're used to seeing it now, but it's not going to look that way on the calculator. So when we enter sine squared of 36 degrees, we're going to put sine of 36 degrees, and now what you have to do is close the parentheses and hit the square button. And I know that that looks to you and me like the sine of 36 degrees squared, but it's not. It's sine squared of 36. I know it doesn't look like it looks when we write it typically, This is a more clear way of writing it, but that's just not how it looks on the calculator. So we've got our sine squared of 36, and now we can say plus cosine of 36, close the parentheses, square that function value, and then hit equal. And you probably remember from the end of section 1.4 that sine squared of an angle plus cosine squared of that same angle is 1. So it probably doesn't surprise you here that we came out with an answer of 1. And now let's look at part B. So here we have sine of 55 degrees times cosine of 35 degrees plus cosine of 55 degrees times sine of 35 degrees. And I guess the most important thing to keep in mind on an expression like this is that whenever you're finished entering the argument for a particular trig function, you've just got to remember to close the parentheses. Otherwise, the calculator thinks that everything you're typing in is the argument of whatever function you've entered. So let's enter here sine of 55 degrees, close the parentheses, and then you could push the times button, but you really don't have to. If you just hit cosine, the calculator interprets that as multiplication, and then 35, close those parentheses, and then plus cosine of 55, close the parentheses, times the sine of 35. And this is the end of the expression, so I don't have to close the parentheses. I can just press equal. And this expression also is equal to 1. Now, they're not all equal to 1. This one just happens to be. Both of these are actually applications of identities that we'll look at in more detail later in the course. But now let me show you what happens if we forget to close the parentheses just one time. So I'm going to put sine of 55, and I'm going to forget to close the parentheses. So now I'm going to go times the cosine of 35, and I'll remember to close that parentheses, plus cosine of 55 times the sine of 35. And now, because I forgot to close that first parentheses, everything that came after this first trig function is inside the parentheses. So it thinks that this entire expression is supposed to be plugged into the sine function, which we know is not the case. And you'll see here when we press enter, it does give us an answer. It's not the right answer, but the calculator doesn't know that that's not what we meant to say. So you really have to pay attention to closing your parentheses when you're finished with the argument of a particular function. Now, you may remember from example 3 that they limited our answer to angles that were between 0 degrees and 90 degrees. But we already know that for each function, there are 2 quadrants where the function is positive and 2 quadrants where it's negative. Remember ASTC. Every function is positive in 2 quadrants and negative in 2 quadrants. But the calculator, when we use an inverse trig function, the calculator only gives one answer. So how can we find that other angle? Well, the way to do that is to use ASTC to determine the quadrant where the other angle has to be, and then treat the calculator's answer as a reference angle. So let's look at that together in example 5. So this says find 2 angles in the interval from 0 degrees to 360 degrees that satisfy each of the following round answers to the nearest degree. Now, we did something similar to this back in section 2.2, but at that time we were working with exact values and our reference angles were always 30, 45, and 60, so there was no calculator involved. But here in part A, clearly this tangent value does not belong to 30, 45, or 60, so we are going to need the calculator to help us with this. Now, this is a positive tangent value, so there is going to be an angle in the first quadrant that has this as its tangent value. So let's restate this in inverse function form so we can say that the tangent inverse of this number is approximately equal to theta. And now you know how to enter this on your calculator to get that answer. And when you do that, you'll find that theta is approximately 52 degrees. I've rounded here to the nearest degree. And now this is one of our angles, but remember there's another one out there. So not only will I use this as an answer, but I'll also use it as a reference angle. So now we need to ask ourselves, what is another quadrant where we could have a positive tangent value? And of course, that's going to happen in quadrant 3. So there's another solution out there that's in quadrant 3, and 52 is its reference angle, okay? And so now we can find the other answer by saying 180 degrees plus 52, and we find that that second answer is 232 degrees. And so in my lab, you would enter 52 and 232 in either order, but as long as you get them both in there, you're in good shape. Now let's do the same thing for part B. And you can pause the video and try this one on your own if you like. And now I'm going to go through it with you. So we know that this is a positive cosine value, and so there is going to be an angle in quadrant 1 that has 0.3287 as its cosine. And we know that to find it, we can restate this in inverse form. So we can write cosine inverse of this number is approximately equal to our angle. And now if we enter this expression on the calculator, we find that theta is approximately 71 degrees. And we know that this is one of our solutions, but it's also a reference angle for the other solution. So what is another quadrant where we could get this positive cosine value? And of course, the other quadrant where cosine is positive would be quadrant 4. So I've drawn myself a quadrant 4 angle. I'm looking for this theta, which you can see is going to be between 270 and 360 degrees. And I know that 71 is the reference angle. And so now I can calculate 360 minus 71 is 289. So the two angles between 0 and 360 that have 0.3287 as their cosine are 71 and 289. All right, everybody, we have reached the end of yet another section in our course, and so I'm going to sign off for now, but I'll see you in the next section, which is going to be section 2.4, where we will look at some word problems together. See you then. Bye.